Download this code from codegive.com, link in the description below. Fixing socks.py coverage drop in urllib3, issue 2386, and beyond a comprehensive guide. This tutorial dives deep into fixing a potential coverage drop issue related to socks.py in the urllib3 library, specifically addressing and expanding upon the issues discussed in GitHub issue 2386, though that issue is now closed, the learnings are still highly relevant. We'll cover the problem, its causes, potential solutions, and how to prevent it from recurring. We'll also provide code examples to illustrate the concepts. Understanding the problem, coverage drops and socks proxy support. Code coverage. Code coverage is a metric that measures the percentage of your code base that is executed when running your tests. High code coverage is generally desirable as it indicates that your tests are thoroughly exercising your code, leading to fewer undetected bugs. Socks.py in urllib3. urllib3 provides support for using socks proxies through integration with the PySocks library, also often just referred to as socks. The socks.py module within urllib3 is responsible for handling the complexities of establishing and maintaining socks connections. Coverage drop scenarios. A coverage drop in socks.py typically means that certain code paths related to socks proxy functionality are not being executed by your test suite. This could be due to missing test cases. The test suite lacks specific test cases that exercise certain socks proxy scenarios, example different socks versions, authentication methods, error handling. Conditional execution. Parts of the socks.py code might only be executed under very specific conditions, example a specific socks proxy server configuration, specific error scenarios during socks handshake. External dependencies. Correctly testing socks proxy support often requires setting up a real or emulated socks proxy server, which can be a complex dependency to manage during testing. Platform-specific issues. Socks functionality can sometimes behave differently across operating systems, leading to coverage differences. Changes in PySocks. Updates to the PySocks library, on which urllib3 depends, can subtly change the way socks connections are handled, potentially affecting coverage. Why is this important? Ignoring a coverage drop in the socks proxy functionality can lead to undetected bugs. Bugs in the socks proxy handling code may not be caught until they affect real users. Security vulnerabilities. Poorly tested socks proxy implementations can introduce security vulnerabilities, such as proxy bypass or information leakage. Reduced confidence. Lower code coverage reduces confidence in the overall reliability and stability of the urllib3 library. Steps to diagnose and fix the coverage drop. 1. Reproduce the coverage drop, if applicable. Install dependencies. Make sure you have the necessary tools installed. Check current coverage. Run your test suite with coverage enabled. The exact command might vary depending on your project's setup, but a typical command is *-cov equals urllib3, specifies that you want to measure coverage for the urllib3 package. *-cov report term missing, shows a report in the terminal, highlighting lines that were not covered by the tests. *test/ specifies the directory containing your tests. Adjust this path if your tests are located elsewhere. Analyze the coverage report. Carefully examine the output of the coverage report, specifically focusing on socks.py. Identify the lines or code blocks that are not covered. The term missing report option is particularly helpful because it points out the exact lines that are missing coverage. To understand the uncovered code. Read the code open urllib3/connection.py, or the relevant module responsible for socks proxy handling in the current version of urllib3. Read the uncovered code carefully. Try to understand why it's not being executed during your tests. Consider conditional logic. Pay close attention to conditional statements, if, else, elif, loops, and exception handling blocks. Ask yourself what conditions need to be met to execute these parts of the code. Trace the code. Use a debugger, example PDB in Python, to step through the code execution and see which branches are being taken during your existing tests. This will help you understand why the uncovered code is being skipped. Set breakpoints strategically in the uncovered code regions. 3. Write new test cases. Identify missing scenarios. Based on your analysis, determine the specific socks proxy scenarios that are not currently covered by your tests. Consider these. Different socks versions. Socks 4, socks 5. Authentication methods. No authentication, username/password authentication, for socks 5, GZAPI. Error handling. Connection refused, invalid credentials, timeouts, socks proxy server errors, DNS resolution failures through the proxy. Specific socks proxy server configurations. Some socks proxies may have specific limitations or configurations that need to be tested. Create new tests. Write new test functions that specifically target the uncovered code paths. Here's a general structure for creating a new test. Isolate tests. Important when testing socks proxy functionality, it's crucial to isolate your tests. This means avoid relying on external socks proxies. If possible, ideally, you should not rely on an external socks proxy server for your tests, as that introduces external dependencies and makes your tests less reliable and reproducible. Use mocking. Use the mock library, or unitest.mock in Python 3.3+, to mock out the actual socks proxy connection process. This allows you to simulate different socks proxy server responses, example success, failure, authentication errors, without needing a real proxy server. 4 mocking techniques for socks tests. Mock socket.socket. The PySocks library ultimately uses the standard socket.socket object to establish connections. You can mock socket.socket to intercept the connection attempts and simulate different outcomes. Mock socks.create_connection, or similar. PySocks may have functions like create_connection that you can mock to control the behavior of the connection process. Patch urllib3.connection.socks proxy manager. This class is responsible for handling socks proxy connections within urllib3. You can mock methods of this class to simulate various scenarios. Here's an example of using mock.patch to mock socket.socket and simulate a failed socks connection. 5. Run coverage again. After adding your new test cases, run the coverage command again. Verify that the coverage for socks.py has increased and that the previously uncovered code is now being executed. 6. Address platform-specific issues. Conditional imports. If your code uses conditional imports based on the operating system, example using sys.platform, make sure your tests cover all possible platform branches. Use ptest.mark.skipif to conditionally skip tests on platforms where they are not relevant. Platform-specific behavior. Be aware that socks proxy implementations can sometimes behave differently across operating systems due to underlying system calls or library differences. If you encounter such issues, you may need to write platform-specific tests or use conditional logic in your test code to handle the differences. 7. Keep up to date with PySocks ***. Monitor updates ***. Regularly check for updates to the PySocks library. Pay attention to any changes in the API or behavior that might affect your urllib3 socks proxy integration. Test against multiple versions. Consider testing your urllib3 socks proxy support against different versions of PySocks to ensure compatibility. You can use talks or similar tools to create isolated environments for testing with different dependencies. Example, handling socks 5 authentication. Let's say you want to test the socks 5 username/password authentication mechanism. You'll need a test case that simulates a socks 5 proxy server requiring authentication and verifies that urllib3 correctly provides the credentials. This example uses mocking, but ideally you'd spin up a test socks proxy. Key takeaways and best practices ***. Isolate tests ***. Use mocking extensively to avoid external dependencies and create reproducible tests. Cover all scenarios ***. Think carefully about all the possible socks proxy scenarios, versions, authentication, errors, and write test cases for each. Use coverage reports ***. Regularly run coverage reports and pay attention to any drops in coverage, especially in critical areas like socks proxy handling. Stay updated Keep your dependencies, urllib3, PySocks, up to date and monitor for any changes that might affect your tests. Clear assertions Use clear and specific assertions in your test cases to ensure that the code behaves as expected. Document your tests Add comments to your tests to explain the purpose and assumptions behind each test case. Continuous integration Integrate your tests with a continuous integration (CI) system to automatically run your tests and generate coverage reports on every code change. This will help you catch coverage drops early and prevent them from accumulating. By following these steps and best practices, you can effectively address coverage drops in socks.py, or any other module, in urllib3, improve the reliability and security of your code, and increase your confidence in the overall quality of the library. Remember that maintaining high code coverage requires ongoing effort and attention. Good luck.